Let's go to page 96, and this is lesson 2.4. This lesson is to use postulates and diagrams. Okay, so let's go and read through the paragraph. It says, in geometry, rules that are accepted without proof are called postulates or axioms. Rules that are proved are called theorems. Postulates and theorems are often written in conditional form. Unlike the converse of the definition, the converse of the postulate or theorem cannot be assumed to be true. So you can be careful about the converse. Okay? So you cannot assume the converse is true. The only time that's true is when you have the biconditional. So that's a kind of quick review. Okay. So over here it says you learned 4 postulates in chapter 1. So postulate 1, ruler postulate in page 9. Postulate 2, segment addition postulate on page 10. So you can go back and look at those up, okay, or just look at your notes. Postulate 3, protractor postulate, okay, and that's on page 24. And postulate 4, angle addition postulate, and that's on page 25. Okay. So the 1 and 3, the 1 and 3 is the 1 is kind of use a ruler, and this is to add, and 3 and 4 are the angles. So this one is to use angles, and this is to add angles. So this is to measure the length and to add length. Okay. So they kind of go, they're very similar. Okay, so now let's go look at some of the postulates. Okay, postulate number 5. It says, through any 2 points, there exists exactly one line. Okay, so again, when you have 2 points, you can draw one line through it. Okay, not more than one, okay, but there's always exactly one line through any 2 points. And postulate 6, a line contains at least 2 points. So a line is made of infinite number of points, but usually when they indicate on the picture, usually they kind of at least show at least 2 points on the line. Okay. Postulate 7, if 2 lines intersect, their intersection is exactly 1 point. So you got 2 lines, they intersect is 1 point. Okay. So postulate 8, through any 3 non-collinear points, there exists exactly one plane. Okay, so when you got 3 points, you will have it contains exactly one plane. Okay, and it's that's a good physical application of that, because if you have a chair or table with 3 legs, then you will never wobble, because the three points will be exactly one plane. Okay, so if you have a chair or table with 3 legs, it will never wobble. But when you have 4, if they are not exactly coplanar, then one of the legs is not on the same plane as the other 3, then you know the table or chair will kind of wobble and rock. Okay. So that's a physical application of that. Okay, a plane contains at least 3 non-collinear points. Okay. So if the 3 points are collinear, then the plane can rotate. Okay, so imagine like, you know, if you have something like this, right? So if this is like a line, okay, if you have all points on the collinear, see, and this is the plane, and then it can kind of rotate. See that? It can rotate. Okay, it can rotate. So that's why you have to have a line. So the 3 points cannot be collinear. So they will spread out like this, and so that you can fit a plane on top like this. See? Okay, you can hold it with the 3 fingers. Okay. Okay. Postulate 10. If 2 points lie in a plane, then the line containing them lies in the plane. So again, if the 2 points are on the plane and you draw the line through those 2 points, it's obvious the line is going to be on the plane also. Okay. Postulate 11. If 2 planes intersect, then their intersection is a line. Okay. So a good example, like if you look at the wall and the ceiling, for example, okay, so wall is a plane, and then the ceiling is a plane. So when they intersect, you can see it's a line. Okay, so you can just look around. So when you're doing the geometry, some of this example, you can just look around the physical object. Okay. Okay. So algebra connection. Okay, you have been using many of the postulate 5 through 11 in previous courses. Okay, like in algebra. Okay. It says one way to graph a linear equation is to plot 2 points whose coordinate satisfy the equation, then connect them with a line. That's a postulate number 5 that guarantee the exact one such line. So again, in algebra, when you're going to graph a line, okay, you plot 2 points and you connect the 2 points, and that's how you get a line. Okay, so that's what the postulate number 5 is talking about. Okay. A similar way to find a common solution of 2 linear equations is to graph the line and find the coordinate of the intersection. So like in algebra, sometimes you're looking for the solution of the 2 equations, right? So you graph one equation, you get 9, and you graph the second equation, you get a second 9, and the way they intersect, that is your solution to the 2 equations. Okay. And so that is kind of the postulate number 7. So that's the application of the these geometries in algebra also. Okay. Now let's go to page 97. Example 1, it says identify a postulate is illustrated by a diagram. So state the postulate illustrated by the diagram. So if 2 lines intersect, then they intersect exactly 1 point. Okay, so again, postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. Okay, again, 2 lines intersect, it will intersect exactly 1 point. Okay, then B, if 2 planes intersect, then they intersect in a line. Okay, so that's postulate 11. Okay, if two planes intersect, then their intersection is a line. Okay, let's go to example 2. Okay, identify postulate from a diagram. Okay, use a diagram to write example of postulate 9 and 10. So postulate 9, it says plane P contains at least 3 non-collinear points A, B, C. Okay, so you can see from this diagram to write postulate 9, right? And you don't have to use A, B, C. You can use other points, but since only 3 points are named, so you have no other choice to use A, B, and C. Okay, but if in some other diagram they have a lot of points, then there can be multiple options. Okay, postulate 10. Okay, point A and B lies in the plane P, so the line N containing AB also lies in the plane P. Okay. So again, if you look at A and B, right, and if you draw the line through A and B, that's the line N. Since A and B are on the plane P, so when you draw the line through it, the line N will also on the plane P. So you can just some of the common sense. Okay, okay, now let's go to the concept summary. Okay, again, these are important, super important for your notebook. Okay, interpret diagram. So when you look at diagram, there are certain things that you can assume, certain things you cannot assume. Okay, so like this one. So by looking at this diagram, okay, you can assume all points shown are coplanars because see here's your plane and all the points are on it, right? So you can assume that all points are on the same plane. Okay. Also, you can assume that angle AHB, okay, so AHB and BHD are linear pair. Okay, so again, AHB and BHD, you can assume that it's a linear pair because AD is on the line, right? It's a straight line. So when you see the picture, you can assume that this is on the same line. The A and D are on the same line. So AHB and BHD, since they're opposite ray form this line, so you can see that they are linear pair. You also can assume that AHF and BHD, so this angle and this angle, they are vertical angles. So again, those are something that's very obvious, so you can assume that. You also can assume AHJD are collinear. Okay, so AH, Okay, they didn't put a dot over there, but H is the dot right over here. Okay, so they didn't put a dot. They should have put a dot over there. But anyway, so A, H, J, D, all these 4 points are collinear. They are on a straight line. Okay, you also can assume that AD, so line AD and line BF intersect at H. Okay, you also can assume that AD and CE intersect at point J. Okay, so there's other things you can assume. Now, by looking at this diagram, there are certain things you cannot assume. You cannot assume that GFE are collinear. See, GFE, you cannot assume that on a straight line. So if you don't see the line going through it, you cannot assume because it may be off a little bit. Okay, so it's not on a straight line. Okay, you also cannot assume that BF and CE intersect. Okay, so you cannot assume that these and this intersect, even though remember the plane and the lines goes on forever, right? But it doesn't tell you one way or the other, so you cannot assume that even the line goes on forever. You cannot assume that they're going to intersect. You just cannot assume that because it's just don't have information. Okay, but the other way around, you also cannot assume that they do not intersect. So again, you don't know one way or the other. You don't know if they're going to intersect or they're not going to intersect. There's just not enough information on here, so you cannot assume either way. Okay. You also cannot assume that BHA, so BHA is congruent to CJA. So you cannot assume that this angle and this angle are congruent, okay? Because you just don't have information that tells you one way or the other, okay? If they're congruent, then you have to see, the little arc, the red arc, then then you can say that they are congruent. But if you don't see those markings, then you cannot assume. Okay? You also cannot assume that all these are perpendicular. Okay? You cannot assume these are perpendicular. Even that may look like it. When you don't see the little marking, the little tiny red square, okay, then you don't know, that means you cannot assume that it's 90 degrees. That means you cannot assume these are perpendicular. Okay? So that's why you have to pay close attention to the markings. Okay? If you don't see the markings, then don't assume. Okay? Okay, now why am I talking about markings? Okay, so this is what I'm talking about markings. Like on example 3, you see the red hash mark. So when you see those markings, they tell you that these are congruent. Okay, so let's go to example 3. It says use a giving information to sketch a diagram. So sketch the diagram showing that line TV intersect PQ. Okay, so you got line TV and segment PQ. So you have to pay attention to the symbol. This is the line, this is the segment, right? So you just follow that. So segment PQ, so they intersect at point W, okay? So that's your picture. The next, also you want to draw it so that the segment TW is congruent to WV. So once you get W, you put a T over here, you put a V over here, and then since they're congruent, means that the lengths are the same, so you put a little hash mark. So that's how you indicate they are congruent, by using the red hash marks. Okay? Okay. Now let's go and look at the paragraph. Okay, perpendicular figures. A line is a line perpendicular to a plane if and only if the line intersects the plane in the point that is perpendicular to every line in the plane that is intersect at that point. Okay, so in a diagram, the line perpendicular to a plane must mark with a right angle symbol. See over here? So what it's saying is that a line is perpendicular to the plane, like this one over here, if it's like a perpendicular to all the anything that's on the plane. Okay, so you have to be perpendicular to the Q, you have to be perpendicular to the AP. Okay, so you see the red mark. Okay. So that shows that they are perpendicular. Okay. Okay, let's go to example 4. Interpret a diagram in 3-dimensional. Okay, so like you have this diagram over here. So which of the following statements cannot be assumed from the diagram? Okay, so A, B, F are collinear. So A, B, F and collinear. That's true. Okay, because you can see the lines over here. So A, B, F are on the same line, so they are collinear. So this is true. Okay, E, B, D are collinear. Okay, so EBD are collinear. So that one you cannot assume because there's no line on it. So you cannot assume that on a straight line. Okay, it looks like it, but for all we know, this can be off by like a hair. Okay, so again, so this one you cannot assume. Now, segment AB perpendicular to the plane S. So here's your AB perpendicular to S. And that's true because you see the red marking right over here. You see the red perpendicular. So it shows that that line is perpendicular to the plane. So this is true. This is correct. Okay, also CD. So here CD is perpendicular to the plane T. Okay? So this is perpendicular to the plane T. We can assume that because the plane T, you see the red marking over here? See, this line is on the plane T, and see this marking shows you that the plane T and plane S are perpendicular. So since they are perpendicular and this line is on the S, therefore this line would be perpendicular to the T. Okay? So again, the marking tells you, what you can know and what you cannot know. Okay. So AF, so 9AF intersects BC at point B. Okay, so here's your 9BC, F, AF, and so this is true. Okay, so that's how you interpret the diagram by just looking at. Okay, if it doesn't show, okay, then you can assume like EBD. Okay, you can assume they are collinear.